I deployed the model, and now I'm going to go ahead and pull in this model's key and the version number. And as this is kind of flowing out, one thing you probably notice is that the iPhone at its side wasn't actually getting picked up. And so this is an example of where you would enter into that iterative process, go back to the video, add a label or two at that kind of side angle of the phone, and it would capture it moving forward. But this is just to show you pretty much how fast you can build and deploy a model on Roboflow Rapid and then pull it into your client-side application. Good morning, everyone. Excited today to be talking about running computer vision AI in a browser. My name is Max Schridde, and I'm a full stack engineer here at Roboflow. So let's go ahead and get started. If I can get my slides working, there we go. Okay, so on a high level, computer vision. So our goal here is to give software the sense of sight. So you can think of this as machines learning to interpret the world and its visual data. So importantly, I want to highlight that we're not just teaching it how to see, quote unquote, but we're also teaching it to look out for us. So there's many different use cases for computer vision in today's world. We see a lot of value in varying industries such as manufacturing and logistics, where we are doing defect detection and inventory tracking. A couple other ones that come to mind are safety monitoring, quality inspection. We work a lot in transportation, energy, utilities. We have some demo videos of computer vision kind of in real time on the slide, just to give you a little taste of what it looks like. Some other interesting fields are healthcare and medicine, where computer vision might actually save the most lives. And some cool examples here are medical imaging. We've seen people say that computer vision is like having a second set of eyes that can never blink, right? So you're not missing things that humans might miss in the medical world. Help guide procedures and training, and then some more exotic kind of use cases, fun use cases. We are powering Wimbledon instant replay. I know, scientists are using this for exoplanet discovery, and kind of the list goes on and on. It's exhaustive, but these are just some kind of high level examples of use cases for computer vision in the real world. So at a high level, like what is computer vision? Kind of a crash course, computer vision 101 in a minute. So there's varying different steps in computer vision. And I like to highlight at the beginning that a lot of this process is iterative, right? So you need to have data. So you're going to be collecting data, building out a data set, and labeling and annotating data. Luckily with Roboflow, this process is really aided and drastically sped up through a lot of our AI assisted labeling tools. And then once you have your data set, you are going to enter the learning phase. So this is where you are going to train a new version of your model based off of your data set. As noted on the slide, you can actually skip these first two steps and tap into Roboflow Universe, which is the world's greatest open repository of computer vision data sets and pre-trained models. So it's a great entry point to kind of get into Roboflow, and also can be used in real life applications and allow you to kind of bootstrap your application to get started before actually having to collect any data yourself. And then you're going to test and evaluate, right? So this is the process of really trying to evaluate how the model performs on data, trying to prevent it from just memorizing the data set that you provide, but getting it to be a more generalized model. And so this is where kind of that iterative process comes into play, where you're going to test, maybe you're going to highlight some places where you can improve your data set, collect more data, improve your labeling, and continue to iterate until you get to that point where you're feeling pretty good about your model and you're ready to bring it out into the wild. At that point, we have another product called Workflows, which is kind of this logic wrapper that allows you to build out computer vision application pipelines. And this is where you can integrate with third-party applications. You can kind of build your own custom logic to evaluate the inference that you're getting back from the model and continue to build into whatever your customer's user story is. And then finally, we get to the deployment phase, and we have another slide on this, but we'll kind of dig into the different deployment options that you have here at Roboflow, and finally land into the option of actually running the model in your customer's browser. So there's a couple different places where you can actually deploy your Roboflow models and workflows. So we have a managed deployment option. So this is running directly on Roboflow's infrastructure in the cloud, and this is an infinitely scalable API. You're then able to run a managed or a dedicated deployment. So this is going to be your own specific servers that are still managed by the Roboflow cloud, but there's not going to be kind of any shared infrastructure. And then after that, you can run self-hosted deployment. So we have an open source and scalable way for you to run your models and workflows on device without actually hitting the network. And this is using our open source inference, Roboflow inference package. And this is what allows you to also run on the edge, on device. As you can see here, a lot of work being done with NVIDIA Jetsons. And then finally, you have the option to actually offload the models running into the customer's browser. And so this is where Inference.js comes into play. So Inference.js is a custom layer that's built on TensorFlow.js. What it does is it almost, the way I like to think of it is it's pretty much allows you to create a distributed compute cluster, but the cluster lives on the client's devices. And there's a couple different benefits of this. At a high level, you're going to have lower latency and greater bandwidth, right? So this is going to be more of a magical user experience. You kind of cut out the middleman of the network requests, and it's just running on device fast in the browser. It's also going to decrease cost for you. So you are off-putting the compute cost onto the user, as opposed to having to spin up your own kind of cluster of GPUs to run computer vision. And then lastly, privacy, right? So there is no network requests. So the data is never going to lose or leave the user's device. And so if they're really concerned with maintaining that, or if you're really concerned with maintaining that privacy of your customers, this is a good option for you. And here you can see an example of one of my coworkers. He is running a model from our universe. The Microsoft Cocoa dataset has been trained and is running in the browser here. And so you can see it's doing a really good job of identifying common objects in his webcam feed. And at the end of this slideshow, we'll actually do a fun interactive demo where you'll be able to interact with Microsoft Cocoa on your device. So getting started with Inference.js is pretty simple. This is assuming that you already have a model trained within the Roboflow ecosystem. You can pull it in from Universe, or you can pull in your own models. And so once you have a model that you want to bring in, all you have to do is grab the identifier, the version for the model, and your publishable key. And then this is what the integration looks like. So you can pull it in via npm package. You can run it as a script source tag. And once you instantiate the Infer engine, then you just pass your data images into the Infer engine and run inference and get the predictions right away. Quote unquote live coding demo. So this is actually a pre-recorded video that I took a couple days ago. So we'll hop into it. And you can see, so I'm actually vibe coding here. I think vibe coding is amazing because we're creating a bunch of tools that abstract away just a lot of complexity and inviting more people into the traditional software engineering space. And this is very similar to the goal at Roboflow, right? Of democratizing visioning and getting people the ability to create computer vision apps, even if they're not ML experts, right? So I one shot, I full transparency, did kind of work on that prompt a little bit, but we're creating a web app here that's going to be integrated with my webcam. And you can see out of the gate, I'm pulling in that Microsoft Cocoa model from the universe. So I haven't had to train or provide any data. And now I'm running it on my webcam. And you can see it's doing a great job of identifying me as a person, but you probably also noticed that it wasn't identifying the iPhone. And this is because of kind of the data that is within the Microsoft Cocoa data set. It's kind of an older data set. So here we're hopping into a new tool, a new product that we're really excited about at Roboflow called Rapid. And this is kind of the beginning of what we're thinking of as CV 2.0, right? Where AI is really steering and humans are just assisting, as opposed to traditionally it's been the other way around. So we have a lot of the AI assisted labeling tools in here. You saw previously that I was generating the predictions for the phone. I can also draw my own custom boxes on here. Uh, and then we collect a couple data points. You'll notice that this is video first, and you're also not really required to collect that much data. I'm going to collect 2 more data points here. It was able to run box prompting on that based off of the previous prompts that I had provided it. And then immediately you're able to test the model that you built and run the model in the browser on whatever the data set is that you provided. So in this case, video. And you can see like we're actually doing a pretty good job of identifying the phone in that video. So I deployed the model, and now I'm going to go ahead and pull in this model's key and the version number. And as this is kind of flowing out, one thing you probably notice is that the iPhone at its side wasn't actually getting picked up. And so this is an example of where you would enter into that iterative process, go back to the video, add a label or two at that kind of side angle of the phone, and it would capture it moving forward. But this is just to show you pretty much how fast you can build and deploy a model on Roboflow Rapid and then pull it into your client-side application. So we've reached the end of my main talking points. And at this point, I'd like to invite you to take a couple minutes. We have a Scavenger Hunt interactive demo. So you can scan this QR code and hunt.roboflow.run should pop up on your mobile device. This is just kind of a fun demo app. So we're again using Microsoft Cocoa and on device. The idea is you just kind of look at the objects that it's asking you to find in your quest, kind of play around with it in your local settings, see if you can capture some images. And one thing to note is there is a question to see if you want to allow the app to capture images or not when you find objects. Those aren't going to be used for anything other than just kind of lighting up the leaderboard. So yeah, please go ahead and get started. If you're having problems with the app, let us know in the chat and we'll give you a couple minutes to play around.
I'm popping back in here to say I may have just cheated a little bit while I was playing the game with my computer monitor in front of me. And a little friend I have called Google Image Search.
Yeah, so yeah, like I said, this is a demo app. It's mainly meant for fun. 2 things to note is, yes, you are able to cheat and screen grab. The other thing I would say is, we are running an older version of Microsoft Cocoa, so it might mistakenly capture some things. We have much better models to be running these days, but this is again just kind of a fun interactive demo. I am seeing we're getting some engagement here. Let me see if I can pop on over and show the leaderboard. All right, yeah. Patrick, I see you at the top. Federico, Angel. All right, this is looking pretty good. Although look at this. It said the bowl and the cup were the same. Backpack. Great job, Federico. I've actually had a hard time getting backpack to pop up on this model. So that's a win right there. Looks like we got 13 active people playing rounds. All right, we'll give this a couple more minutes and then I think we'll go ahead and wrap it up.
I have a question. So Patrick, obviously, the bottle there is a photo of Google Images. Max, is that something that we could use computer vision to detect? Could we use clip or something to try and find if somebody was cheating in the game?
Yeah, 100%. Again, like I said, I think there's definitely some great optimization ideas for this app. And if anyone has any, please share them in the chat. This is kind of a fun side project that we're working on. But yeah, this would be a perfect use case for computer vision, right? So to kind of identify whether or not the data that's coming through is actually displayed on some type of virtual screen is kind of a precursor that you could use to identify the initial kind of image or stream that's coming through. And then based off of that, make a decision on whether or not you want to actually run the Cocoa model to identify any objects. So yeah, using computer vision to solve computer vision problems. I love it.
Yeah, I I'm incredibly excited seeing these examples because I'm seeing more and more people build things on their phone because it's the thing they have in their pocket. And so I definitely want to like go outside and see if I can find like a cat wandering the streets or a dog with its owner and try and get myself up on the leaderboards.
So one of the fun things I want to do with this app too is continue to expand kind of what models you can run and what are the kind of object lists that you can try to identify. Right now, this is pretty slimmed down to just kind of some common stuff you might find in your office. You know, expanding this to like you're mentioning, kind of some more fun, like, hey, maybe I have to go outside and find a car, or find a cat or a stop sign, and kind of make this a more exploratory experience. So those are all definitely in the queue.
Yeah, whenever I see computer vision, I'm like, what can we add? But I do have a question. Like earlier you showed the lovable prompt that you ran and you were kind of vibe coding this application. How long did it take you to write that? And like for the audience, do you have tips on like how they should be thinking about prompting a cursor or lovable or VC or these other tools for building a vision app?
Yeah, that's a great question. I would say precursor. I am not an expert vibe coder. I actually was like not enthusiastic about vibe coding for a long time, seeing as, you know, I'm an engineer, and I guess I didn't really fully trust it. And then this experience was kind of like a 180 perspective shift for me. So the hardest thing about vibe coding the app, actually, so if you haven't done it before, it's a chat interface. I did not touch any code. That was my goal going into building out this app. It's kind of to test to see how powerful and what are the limits of vibe coding. And I was very impressed. I would say the hardest thing that I ran up against was actually the prompt got large, mainly because I was just trying to be specific about what I wanted it to build. I found that like, don't just tell it, hey, build me a computer vision app. You kind of have to be like, hey, build me a computer vision app that has a homepage. I want it to have a play view where it's going to be integrated with a webcam. And then I want a leaderboard. So being very specific around kind of what are the views you want it to have. And then it got long because I had to give it some specific pointers about how to integrate with Inference.js. Not the actual like download the package and run the engine, but more so like what is the schema that it can expect to be returned in the prediction JSON blob. And I think this is something that at Roboflow we know we actually have to improve via, you know, creating LLM.txt files, things that are easier for these kind of large foundation models to pull in, so that I don't actually have to pull that documentation in. It actually is able to just grab that from the internet, right? So I would say that prompt over time will get shorter as we continue to improve our documentation over here at Roboflow. Yeah, the last thing I would say is that probably I tested that prompt 3 times and continued to improve it as I found bugs in the apps that it was building. And then the 4th time, I would say, was able to kind of one fell swoop, single prompts, build the app out.
That's amazing, especially for something like advanced as a scavenger hunt. Is there like, are you planning on, I guess, open sourcing the prompt, or are we gonna write something so that people can get that kind of condensed prompt for building vision apps?
100%. I think, like I said, our priority in these next couple of weeks is improving the documentation for integration with the LLM so that we can actually shrink that prompt down. And then the plan would be to definitely publish that in some type of blog post, or maybe even we start building out a library of prompts that people can use with kind of vibe coded templates, if you will. So a couple different ideas to play around with there, but yes, to answer your question, we want to get this out for the people to use.
Nice. I think that's all the questions I have. Like when you first did the demo, I played around with it and I'm like, this is so cool. So yeah, it's nice to know that we can have like state of the art vision technology running on our phones, on device, and we can take it around wherever we go.
Couldn't agree with you more, James. Thanks for your questions. I see a chat right now about training custom VLMs using this tool, which I assume to be Rapid. So as of right now, Rapid is focused mainly on we're releasing it with one task type in mind. So it's going to be primarily object detection As a fast follow, we're going to have instance segmentation as well. I think if you are looking to train and engage with DLMs right now, the Roboflow platform is the best place for you to do that and to incorporate them into your workflows. But we love getting any and all types of ideas and feedback around kind of what would be the best features and integrations for us to offer with all of the products that we're developing. So definitely we'll bring this one back to the team as well.
I was gonna say, since we still have some time today, actually I see one more question, but I was going to mention to the audience, we have a couple different experts here on various things related to computer vision and then running models in the browser. If you have any specific questions for us, just a reminder to put them either in the chat or perhaps if you're feeling kind of brave and you want to come off of mute, you could always do the raise your hand reaction in Zoom and we could call on you and then you could unmute yourself and ask us some questions. I have one of my own that I wanted to piggyback on. James stole my question about the vibe coding prompt. I was totally going to ask about that. In the Scavenger Hunt game that we all just played on our mobile phone, the model that was loaded into the browser you mentioned is the Microsoft Cocoa model, right? Could you tell me a little bit about is that the best model in terms of performance? If I wanted to kind of make my own app that was going to be running in a web browser, should I just be using that model that we used or something else? Could you kind of talk about the availability of different models and performance?
Yeah, definitely. So Microsoft Cocoa is a very large historical data set with, I don't know, probably around 200,000 images, I believe, maybe an order of magnitude larger. I think it's 200,000. But I would say this is a great kind of data set to use just for a fun kind of demo app like this. I would say traditionally, if you're building out your own computer vision model that you want to run in your own production application, that's typically not the model that you would be pulling in. Correct me if I'm wrong here, but James, but I think that this is a very large data set. It's not optimized. It can be slow. And also the data set is old, right? So like we saw, it wasn't able to kind of identify iPhones natively. And so I think here at Roboflow, I kind of guess I would compare it to foundation models and foundation models being these big LLMs and ChatGPT, et cetera, as it compares to kind of the computer vision models that we're building here at Roboflow, which are kind of fine-tuned, optimized, smaller models that are going to be a lot faster and a lot more accurate if you train them on the specific data set of whatever your use case is, right? So Microsoft Cocoa is a great starting point. You could use that to, again, use it as a foundation for a lot of the AI assisted labeling tools that we have in platform to help you kind of get your data set labeled faster. But I would probably say that when you're moving into a production application and kind of a specific use case for your customers, that's something you would want to distill and fine tune into kind of a more specialized computer vision model. And the other thing I'll call out is the Microsoft Cocoa model version that we're running in the Scavenger Hunt app isn't actually built on top of the RF-Deader architecture. If you haven't heard about it, RF-Deader architecture is the latest and greatest state-of-the-art family of models that we're developing here at Roboflow that really thrive and they thrive for low latency, extreme accuracy. We have a lot of benchmarks. I don't know if Patrick can make them available, but if you're interested in Pareto curves, you can see just kind of how we're blowing all of the other models, YOLOs, et cetera, out of the water with this new RF-Deader architecture. And so even just bringing in that architecture would really optimize the vision models that you're building. I hope that answers your question, Patrick.
Totally. I was just looking for the slide with the chart that you were just mentioning on it. Maybe we could take a look at that a little bit later. Let me see here. We have a
One
post
one
reaction.
question I did notice: the API keys that we're using there is no security risk. Those API keys are intended for use in the browser, in the public sphere. So that is not an issue, and it is not the same key as the private keys that you would be integrating with in your more backend integrations.
Beautiful. Yeah, I was about to actually ask that one. All right. Well, that wraps up my line of questioning for you, Max. And I think that we have gotten through the audience questions so far. So thank you very much for coming and sharing this fun project that you've been working on that also serves as a really cool proof of concept for other people who might want to be bringing their computer vision models into web browsers to make some fun or useful apps. And then thank you to the audience for coming to join us. If you are watching a recorded version of this somewhere and you want to join live, please go to roboflow.com/webinar and go out there and please find some vision problems to solve for the rest of the day. And looking forward to hearing what you all are building in the future. All right. Thank you very much.
Thanks, everyone.